Investigating a switched outlet showing 26 volts when the switch is in the off position, but 120 volts when on, requires a systematic approach. Several factors could contribute to this unusual reading, ranging from wiring issues to the characteristics of the connected load. Let's explore the possible causes and troubleshooting steps. Firstly, a faulty switch wiring configuration is a primary suspect. The switch should be wired such that the constant hot wire connects to the common terminal and the wire leading to the receptacle connects to the load terminal. An incorrect wiring arrangement can lead to voltage leakage or incomplete isolation when the switch is open. Secondly, consider the possibility of a split circuit panel. In panels with split-phase breakers, the receptacle and switch might inadvertently be connected to different phases. Although less likely in a new circuit, this configuration can create a voltage differential even when the switch is off. Thirdly, the inductive nature of the garbage disposal itself could play a role. As an inductive load, the disposal generates a magnetic field during operation. When the switch is open, this magnetic field can induce a voltage in the wiring through electromagnetic induction. This induced voltage might be measurable at the receptacle. Fourthly, voltage drop along the wire run can influence the voltage readings. A long wire run, especially under a heavy load like a garbage disposal, can cause a significant voltage drop. When the switch is open and the load is removed, the voltage at the receptacle might recover slightly, but not completely, potentially settling at the observed 26 volts. Fifthly, voltage leakage due to faulty wiring or components is another plausible explanation. Damaged insulation, loose connections, or failing components can allow a small amount of voltage to leak through, even when the circuit is supposed to be open. This leakage current, though small, can be enough to register on a voltmeter. Sixthly, electrical interference from other devices or nearby wiring can introduce electrical noise into the circuit. This noise can interfere with voltage measurements, leading to inaccurate readings. Radio frequency interference or electromagnetic interference from other appliances or equipment can sometimes manifest as a phantom voltage. Troubleshooting this issue involves several steps. Firstly, carefully examine the switch wiring. Ensure that the common and load terminals are correctly connected. Refer to the switch manufacturer's instructions or a wiring diagram to confirm the proper configuration. If the wiring is incorrect, correct it and retest the circuit. Secondly, use a different voltmeter to verify the voltage readings. Sometimes a faulty or inaccurate voltmeter can produce erroneous results. Try using a different meter to confirm the 26 volts reading when the switch is open. If the second meter shows a different reading, the original meter might be the source of the problem. Thirdly, disconnect the garbage disposal from the circuit to eliminate any inductive effects. Remove the wiring connections to the disposal and then measure the voltage at the receptacle with the switch open. If the 26 volts reading disappears, the disposal's inductive characteristics are likely contributing to the issue. In this case, consider using a line filter or surge protector designed to mitigate inductive voltage spikes. Fourthly, trace the wiring run to identify any breaks or interruptions in the 12/2 cable. Inspect the cable for signs of damage such as cuts, abrasions, or kinks. Check all connections at junction boxes, receptacles, and the circuit breaker panel to ensure they are tight and secure. A loose connection or damaged wire can cause voltage leakage or create a path for induced voltage. If you are unable to identify and resolve the issue, it is highly recommended to contact a qualified electrician for assistance. Electrical work can be dangerous, and a professional electrician has the training, experience, and tools to diagnose and repair electrical problems safely and effectively. An electrician can perform a thorough inspection of the wiring, circuit breaker panel, and connected appliances to pinpoint the cause of the voltage reading and implement the appropriate solution. To further elaborate on each of the potential causes, let's delve into more detail. Regarding faulty switch wiring, it's essential to understand the function of a switch in a circuit. A single-pole switch, commonly used for controlling lights and receptacles, has two terminals, the common terminal and the load terminal. The common terminal receives the constant hot wire from the power source, typically the circuit breaker panel. The load terminal connects to the wire that feeds the device being controlled, in this case, the receptacle. When this switch is closed, it creates a continuous path between the common and load terminals, allowing current to flow to the receptacle. When the switch is open, it breaks this path, interrupting the current flow and energizing the receptacle. If the switch is wired incorrectly, such as connecting the constant hot wire to the load terminal and the wire to the receptacle to the common terminal, the circuit may still function, but it can create unexpected voltage readings when the switch is open. This is because the circuit is not completely isolated, and a small amount of voltage can leak through the switch or through capacitive coupling in the wiring. In the case of a split circuit panel, the issue arises from the interaction between different phases of the electrical supply. In a typical 120 volts electrical system, power is supplied by two phases, often referred to as phase A and phase B. Each phase provides 120 volts relative to neutral. However, the voltage between phase A and phase B is 208 volts. If the switch is connected to one phase and the receptacle is connected to the other phase, there will be a 208 volts potential difference between them. When the switch is open, this voltage difference can manifest as a voltage reading at the receptacle, even though it is not energized in the conventional sense. Inductive loads, such as garbage disposals, motors, and transformers, have a unique characteristic: they generate a magnetic field when current flows through them. This magnetic field can induce a voltage in nearby conductors, a phenomenon known as electromagnetic induction. When the switch is open, the garbage disposal is not actively drawing current, but the magnetic field generated during previous operation can still induce a voltage in the wiring. This induced voltage is typically small, but it can be enough to register on a sensitive voltmeter. The magnitude of the induced voltage depends on several factors, including the strength of the magnetic field, the proximity of the wiring to the disposal, and the frequency of the alternating current. Voltage drop is an inherent characteristic of electrical circuits. As current flows through a wire, it encounters resistance, which causes a voltage drop along the length of the wire. The amount of voltage drop depends on the wire gauge, the length of the wire, and the amount of current flowing through it. In a long wire run, the voltage drop can be significant, especially when the load is high. When the garbage disposal is running, it draws a substantial amount of current, which can exacerbate the voltage drop. This can result in a lower voltage at the receptacle compared to the voltage at the circuit breaker panel. When the switch is open and the load is removed, the voltage drop is reduced, and the voltage at the receptacle may recover slightly. However, if there are other loads on the same circuit, or if the wiring is undersized, the voltage may not recover completely, resulting in the observed 26 volts reading. Voltage leakage, as mentioned earlier, is a consequence of faulty wiring or components. Damaged insulation, loose connections, or failing components can create a path for a small amount of current to flow, even when the circuit is supposed to be open. This leakage current can create a voltage drop across the impedance of the wiring, resulting in a voltage reading at the receptacle. The magnitude of the leakage voltage depends on the amount of leakage current and the impedance of the wiring. Electrical interference, or noise, can originate from various sources, including radio transmitters, electronic devices, and power lines. This interference can couple into electrical circuits through electromagnetic radiation or conduction. The noise voltage can then interfere with voltage measurements, leading to inaccurate readings. To minimize the effects of electrical interference, it is important to use shielded cables, filter the power supply, and ground the equipment properly. In addition to the troubleshooting steps mentioned earlier, it is also helpful to inspect the circuit breaker panel for any signs of problems. Check the breaker for proper operation and ensure that it is securely seated in the panel. Look for any signs of overheating, such as discolored or melted insulation. If the breaker is faulty, it may not be providing adequate protection, which can lead to voltage fluctuations and other electrical problems. Furthermore, consider the possibility of a neutral wire issue. A loose or corroded neutral connection can cause voltage imbalances and erratic readings. Inspect the neutral connections at the receptacle, the switch, and the circuit breaker panel to ensure they are tight and secure. If you suspect a neutral wire issue, it is best to consult a qualified electrician, as diagnosing and repairing neutral wire problems can be complex and dangerous. When checking the wiring, always de-energize the circuit by turning off the circuit breaker. Use a non-contact voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Work in a well-lit area and avoid distractions. If you are not comfortable working with electricity, it is always best to call a qualified electrician. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. In summary, the 26 volts reading at the switched outlet when the switch is open could be due to a variety of factors, including faulty switch wiring, a split circuit panel, inductive effects from the garbage disposal, voltage drop, voltage leakage, or electrical interference. By systematically troubleshooting the circuit and considering these potential causes, you can identify the source of the problem and take the appropriate corrective action. If you are unsure about any aspect of the troubleshooting process, or if you are not comfortable working with electricity, it is always best to consult a qualified electrician. They have the expertise and equipment to diagnose and repair electrical problems safely and effectively. Always prioritize safety when working with electricity.